was a tough one to put together, and so what I decided to do is sometimes when I present, we go pretty detailed into a specific research topic that we're dealing with, and I figured that would go right over everyone's head. So I'm going to fly through a lot of different things that we're working on at WSU. And I'm going to give you some context about which to think about it in terms of energy use in agriculture and energy production. So I'm going to give you some introductions to energy and agriculture and then present a conceptual model for how I've organized this talk. Look at a couple of relevant Pacific Northwest ag systems and what we know about the energy use in those systems. And then the model is actually this concept of efficiency, substitution, and redesign. So these are the kind of three legs of how we've organized a lot of our research that we're doing. And then some final considerations. So, can you see this side of it? Well, I'll slide back a little bit. So basically, these two charts that you're looking at here are attempts to kind of assess how we use energy in our agriculture and food systems in this country. And the one on the left is kind of the big one. So this is total food systems energy use. That's everything from seed to kitchen table. In fact, the one thing it doesn't really have is what goes on after the kitchen table, which is an area of a lot of our work. But you can see we have big amounts of energy use that are used in things like home refrigeration, preparation, processing, all of that. Transportation is significant, but it's not nearly as significant as most people think it is. And there's been a lot of work on food miles. I'm not going to talk about that tonight, but it doesn't tend to be the issue that people think it is. Agricultural production. It's about 1/5 of the total energy we use in the plate of food. And this is how it's broken up. And I'm going to focus mostly on the production system and then the waste management system tonight because that's where our work is and most of our expertise. But I want you to look at a couple things. Diesel fuel is obviously a big part of the energy use in our current agricultural systems. Electricity, in some cases, that doesn't tend to be as big here as it is in the Midwest. And it does tend to be a bigger part in confined animal feeding operations as opposed to crop production. But the big one is fertilizer production. And almost all of that has to do with the supply of nitrogen. And so I'll spend quite a bit of time talking about that issue because that's one where we have a lot of potential to actually improve our energy use in our systems here. And a little bit on herbicides and pesticides. Okay, so here's the conceptual model. And what I've done here is I've taken ideas from this researcher, Stuart Hill, from University of Western Sydney, and his ideas are essentially this efficiency, substitution, and redesign concept. And then this idea of precision agroecology from Dave Huggins, who's actually a USDA Ag Research Service researcher for dryland systems in Pullman. And the concept here is there's multiple ways that we can attack this issue of sustainability in agriculture. And I'm going to focus on energy use here today. And so we have some things of which you actually are doing quite a bit in this area in terms of conservation. And Roland Sherman, tremendous career helping move this county along on the issues of conservation. Substitution. We have a lot of materials that we use that were based on petrochemical inputs, much of which we can actually substitute another product for that. Essentially, that's what a lot of organic agriculture has become. We substitute a product that comes from a petrochemical base with another product that comes from a biological base. And then this concept of redesign. Sometimes we're going to come to a wall where we just can't get any more efficient, there's nothing else we can substitute, and if we're going to make some improvements in our energy use or other sustainability issues, we may need to rethink the way that we're doing it. But we need to be working on all of these. We can't sell out efficiency and conservation just to work on redesign. Okay, so looking at a couple systems. Obviously, wheat is a pretty important system in this area and for much of eastern Washington. And what we've got here is essentially the energy required to produce wheat. And kind of two things, the crop fallow zone and then the annual cropping zone. And I'm going to talk about these in just a moment. But basically, conventional tillage versus no-till, there isn't a whole lot of difference in the crop fallow zone, just because there's not a lot of difference in the amount of tillage they do, plus the additional chemical use, which has an energy issue. But it's about 3% savings per bushel of wheat. When we come down to the annual cropping zone, it's kind of interesting how this comes out in terms of the change. And this is not just a wheat-based system. The difference here is we have a P in this rotation. We don't have a P in this rotation. So, and actually, yeah, that's conventional, so it does include tillage. So even though we included tillage, which has a higher energy use per acre, energy use per bushel in the fuel, the fact that we put P in that rotation and that's providing nitrogen to that rotation actually means that the total energy use in that system is lower. Now we could improve this system even more going to a no-till system. We've been doing some work in Pullman in terms of looking at reduced tillage in organic wheat systems. And it's kind of interesting because we're using considerably less energy per acre. But what's really stunning is it's taking more energy per unit of output with the organic system, just because it doesn't yield as well. So we're giving up so much yield potential in that particular system. And that's a really important thing to think about. Energy use in an agricultural system is not just about managing the input side, it's about managing the output side. So you may reduce your inputs and actually also at the same time reduce your outputs, and that's no more efficient, not necessarily. An orchard system, and this study is actually a fairly substantial study, a long-term study in Zillow, Washington by John Reganold, who is a Regents professor at WSU, and this is the study that made him. Published it in Nature, which is a very high-end journal. And what he did is he compared an organic and integrated and conventional orchard system, and his conclusion was the organic system used considerably less energy than the conventional system or the integrated system. Well, and David Granatstein, who came and presented to you a couple months ago, he and I looked at that when we were preparing another presentation, and we looked at a couple numbers. We looked at fertilizer inputs and weed control, and we thought, something is wrong here. So fertilizer input, only 311 megajoules per hectare, that's nothing. So we asked what John did, and he said, well, we charged all that energy to the chicken farm where we got the compost. And David was kind of, well, you can't just charge all that energy somewhere else and not consider it in the system, especially if you had to truck it 150 miles to Zillow. And then we looked at this one, the weed control. So weed control in an organic system, basically that means going out with a hoe and turning around and coming back in 6 years. And we said, there's an issue with that too. So David and I sat down and we kind of re-crunched these numbers. And in doing that, David also looked at the fertilizer and weed control on the conventional one and said, you know, his numbers are awfully high. So we recalculated based on some of David's work with more modern orchard systems. And look, bottom line, they aren't that different. But what really came out of this was figuring out fertilizer use is a key, because that's one of the few things we can really manage well, and figuring out some better weed control, regardless of the type of system or places where we could really have an impact. Okay, so I want to move into the efficiency concept here, and you guys do a really good job of this in this region in terms of using available technology to do a better job, and most of that's been around soil conservation. But the kind of default benefit is that there's potential for saving fuel and fertilizer and pesticides as well. And so just a couple of pictures here. Weed seeker sprayer, direct seeding. We've done quite a bit of work on the Cook farm in Pullman in terms of monitoring that farm intensively so we know how we're using energy, nutrients, and all kinds of other things. And then one that many of you may not know as much about in this region, because I think you don't even have a site yet, or maybe you have one now, is the Ag Weather Net. We made a major investment at WSU in building the Ag Weather Net to provide decision support tools for producers essentially around pesticide management. And we use it extensively in the Wenatchee Valley where I'm located. In Prosser, they use that a lot. But basically, the knowledge base and the technology coupled of how do we better manage the different chemicals that we use in agriculture. We do it for many reasons, but energy savings is one of those.